For years, smart metering projects across Europe followed a fairly predictable model, and that made sense at the time. But as electrification accelerates and the grid edge becomes more dynamic, many are now asking a bigger question. Is connectivity still just a technical choice attached to a specific use case, like smart metering, or has it become something more fundamental to how utilities operate and evolve?
This is Powering the Future, a podcast series brought to you by Smart Grid Forums. One planet, one power grid.
Joining me today to discuss this are Neil Bosworth and Thomas Weisshaupt of Wirepass. Hello, Neil, Thomas. Thank you so much for joining us today. It's great to have you on the podcast.
Thanks, Mandana, for having us. We appreciate talking to you and having a good time.
I'm honored to be here. Thank you.
Thank you. Well, now, before we get started on the conversation, it would be great for our audience to know a little bit more about you and about Wirepass. So perhaps you can give us a quick introduction to your roles, responsibilities, the organization, and some of the products that you work with.
Yeah, if I may start, because I have already an 8-year tenure with Wirepass, and I might jump back in time a little bit and tell you what fascinated me in Wirepass 8 years ago when I started. It is the win of a smart metering project as a connectivity provider they had back in 2014-15, the Nordic countries, where I was working in smart metering before, in the smart metering connectivity domain for telecom sector, and realized that this was the one and only rollout that I saw that was in time, budget, and quality. And one of the main drivers for that was the connectivity layer, which in that case was a Wirepass connectivity layer offered as a software IP solution, which was our business model for a long time, and implemented then by meter vendors and still in operation with 1 million meters in one RF mesh network in Oslo today and for sure in the future. And during the last 10 years, we have removed a lot of, let's say, regulatory and technological barriers to bring this amazing technology outside the Nordics into other geographies. And we have been, for example, solved the issue of standardization. So we brought a lot of our know-how, a lot of our patents into the newly created NR Plus standard. We have solved the spectrum problem because NR Plus standard has been defined within ETSI for a 20 megahertz spectrum available in more than 110 countries. And we have for sure been also evaluating our product, developed it further, made it more mature so that we now can serve with our Wirepass platform in India. And I would let Neil introduce that one.
Mm-hmm. Yeah, thanks, Thomas. Just in case you missed it at the start, my name's Neil Bosworth, and I come from a background of electronics, communications, and very heavily influenced towards IoT and smart metering. And I joined Wirepass a couple of years ago as product marketing for our smart energy initiatives. And our product is the Wirepass platform, and it's really made up of embedded firmware that's integrated directly into IoT devices, typically smart meters, and together with network management software, which would typically live in the head-end system in the other end. And without going into too much detail, the platform contains and integrates all the smarts that a commercially deployable IoT network needs. So devices equipped with Wirepass intelligence automatically form a dynamic, self-healing wireless mesh network. And as more devices are added over time, the network expands and strengthens seamlessly. And today we're connecting around 15 million smart meters with RF mesh across Northern Europe, as Thomas was saying, in Oslo, and predominantly in Asia. Now, RF mesh is a widely used connectivity strategy around the world for smart metering applications. And in much of Europe, it's been limited due to these radio spectrum constraints that Thomas was mentioning. But what's especially important for Europe now is that Wirepass RF mesh networks are built on this open radio communication standard called NR+. And this is published by ETSI, it's standardized. And it's a standard that natively supports RF mesh technology. So NR+, it operates in its own dedicated radio spectrum, and that removes these regulation barriers, giving utilities a clear path to deploy RF mesh at scale.
Right. Okay. Very impressive. Thank you for that background. So, Neil, traditionally, connectivity for smart metering has been treated as a supporting technical component. Why is that no longer sufficient, do you think?
Well, connectivity has moved from supporting convenience to being mission critical infrastructure. In these early rollout waves, and I'm, let's say, mature enough to remember them, the goal was simple. Utilities needed reliable remote meter reading, and the communication was just a tool to improve efficiency. And in that context, choosing the lowest cost compliant solution, well, that made perfect sense. But today, that same communication layer carries operational data, control signals, and software updates. And it supports nice things like demand-side flexibility and also the transaction settlement, regardless of the governance. So the meter today is no longer just a cash register. It's a connected node in this vast digital distributed network. So connectivity becomes a vital component of grid operations, and the stakes have risen massively. You're no longer buying a supporting technology. You're investing in infrastructure that must perform reliably and for decades and adapt as new use cases emerge. Now, connectivity is core to grid resilience and market participation, and CapEx alone can't drive the decision. It's now a life cycle stability and upgrade path discussion, and that matters much more. So the conversation shifts from upfront costs to long-term total cost of ownership.
Right, I see. And how are future systems needs reshaping what connectivity has got to deliver?
I mean, we cannot underestimate the transformation that the grid is undergoing, or the energy system is undergoing today, especially in Europe. This is historical. Yeah? If you said in 1850 that every household in the future will have an electricity connection and supply, and we will have all these devices, most people would have called you crazy. And today we are talking about not just net zero, especially in Europe, we are talking about a lot of geopolitical and a lot of independence topics, technology independence topics, but also it's becoming swiftly more and more efficient to utilize decentralized energy resources like storage, EVs, and so on. So the electrification that is happening for heat and mobility cannot be underestimated, and it's an economic decision. It's not an ideological decision. I want to stress that. Yeah? This has a tremendous impact on the grid and on the energy system as such, as we all know. Yeah? And so connectivity, as Neil said, is becoming more holistic decision than a use case decision. Yeah? In smart metering, we talked about use cases. Okay, what is the technology that fits? And if there was a kind of, let's say, lack of SLA or something like that, some data was coming in a couple of minutes later, it didn't matter because it's billing data mainly. Yeah? And we must acknowledge now the complexity that is happening at the grid edge. Yeah? Maybe it's not just the meter that needs to be connected. Yeah? Maybe we need to connect home energy management systems to the energy grid as well, in the same secure manner as we do with the smart meters today, concerning privacy, concerning security. And we must say that data is a critical layer for the resilience of the grid in the future.
Right, okay. Now, if connectivity was initially deployed to support automated meter readings, what happens when it suddenly has to support all of these other roles, services, and market interactions? Does that change how utilities should think about connectivity decisions?
Yeah, I'd say it certainly does, because the use cases evolve, but the infrastructure, well, that just remains. So if you choose connectivity purely to optimize, say, smart metering today, you risk constraining all of tomorrow's applications, and we may not know what they are today. So communication networks typically last as long as the devices they support. So if you lock yourself into a solution optimized for low bandwidth periodic reads, well, you might struggle when you need higher density bidirectional flows or data from additional grid edges, as Thomas was saying. connectivity should be chosen based on the long-term architecture of the energy system, not on single functional requirements. What do you say to that, Thomas?
Yeah, I think there's a very nice study from World Economic Forum about the future innovations that's needed on the grid edge. I can highly recommend that. And this indicates for Europe that the main challenges for the energy system and the grid are flexibility, provisioning, and competitiveness. So both together. And sometimes competitiveness is understood as the cheapest generation or the cheapest battery or the cheapest solar panel or the cheapest available meter. And then you put these into combination. But on a system level, this requires much more effort to bring the, let's say, last mile into the system, not only technically to maintain the system, to maintain the electricity supply, but also economically to stay competitive, to add these assets into the revenue streams of the energy system. And we cannot do that with determined connectivity, like a second use of existing networks, for example, like we see in the mobile world, or determined network that can only send a couple of data points per day. Because what we see is a tremendous multiplication of data points, a tremendous multiplication of decisions to be made decentralized at the grid edge. And it's about us to decide how do we tackle the risk of failure of connectivity or the risk of not having the sufficient non-repudiation and reliability for making financial transactions at the grid edge so that you can earn money with providing flexibility, because that's also part of the European competitiveness. And they have a big chance here.
Well, for decades, the electricity system itself was highly centralized. And what does the involvement of the power grid towards decentralized generation, storage, and flexibility at the grid edge mean for how we think about communication architecture?
The grid edge reality, as I described, is there many more data points, many more metering points. And on the competitiveness side, on the market side, we will see, and we already see, many more market roles that require this data for further processing, not just to manage the grid, which is already a science for itself, but also to serve the different governance models. And if connectivity is not decided strategically to serve also in the needs of these markets in the next 10 years, even if we have a lot of unknown unknowns, we must handle this. And the main question that I have here is, do we build a separate connectivity infrastructure for electrovehicle integration or wall boxes, or do we reuse and use the experience of the smart metering infrastructure and enhance that with the right technologies? And I strongly believe we require a system view on this exact handover point of electrons and information between the grid and the local premise, and require this so-called local orchestration, creating local flexibility markets depending on the needs in the different countries, on the existing infrastructure and so on.
Yeah. I mean, what I'd like to say to this is that as the grid becomes decentralized, communications must evolve with it. So traditional communication models, well, they're centralized. So data is sent to a single point which process it and instructions flow back out again. Where in the case of PLC with smart metering, data goes to a concentrator which relays data from the meters behind it and sends it back again. And that worked when energy flows were predictable and data volumes were low. But this world's changing. Distributed energy systems needs distributed communication. So networks must support local resilience and distributed routing. And we're kind of lucky in our RF mesh networks, self-healing capabilities allow data to reroute automatically, which means devices can communicate through multiple paths and adapts to changes instead of relying on a concentrator to extract data from increasingly noisy power lines. So if coordination depends on centralized nodes, you create these bottlenecks and single points of failure. And with millions and millions of devices interacting in real time, that risk just becomes unacceptable, because AMI is no longer about just billing. Its real value is in enabling services that reduce grid investment and unlock this flexibility. And here's the key point. Communication should mirror the physical grid. If the power system is distributed and bidirectional, but the communication layer remains centralized, you create structural misalignment. A decentralized grid logically requires decentralized communication, so the architecture must evolve in the same direction as the energy system itself.
Right, okay. And how should utilities actually evaluate connectivity strategically?
Well, that's, to me, this is not a case of reinventing the wheel. Utilities could use the same framework as they apply to the energy policy objectives, which is affordability, reliability, and sustainability. So affordability should mean cost over the full life cycle, not just the upfront capex, because, as I said earlier, total cost of ownership matters more than just a purchase price.
Mm-hmm.
When we look at reliability in connectivity, this should mean the performance. And this is the performance that supports grid stability. So the communication layer must be as dependable as the energy system itself. And when we look at sustainability, that should mean the technology, the connectivity technology can evolve with regulation and new use cases, and it must adapt as the grid changes. If a communication network is switched off before the devices it connects reaches end of life, that creates risk and significant additional cost. And we see this happening today with second-grade rollouts needing upgrades due to end-of-life connectivity networks.
Right, okay. And why is this discussion particularly important for Europe right now?
So first of all, let me go back what Neil said. These KPI-driven standards that the utility world is basing all their investment decisions on, is the same when we use that for the connectivity. We have been taking this as our key design principles when we design the standard and our platform, because we learned over the last 10 years that there must be a kind of orchestration, an optimization function of these three: reliability, sustainability in terms of longevity of business operations, as well as affordability, which is for sure a key element for the consumer as well.
Mm-hmm.
Bringing these three in a kind of optimization function for the connectivity has never been done. So the last 5% of the coverage, for example, the last 5% of the data in AMI projects were always the most expensive ones. And we have been looking at these last 5% because you cannot operate a full system, logic and processes and market roles and reliability and resilience of the grid when you do not cover the at least 99.9%, which we have proven on the proprietary side and can proven now with the standard side. Just to complement what Neil said, and this is coming back to your question about Europe. This is exactly the point. This is a European standard. It has been developed by European companies. It has been enhanced by ETSI, or it's managed and owned by ETSI, which is the European Telecommunication Standardization Institute.
Yeah.
And on top of that, it has been acknowledged as a standard that serves also the 5G requirements, meaning that we are acknowledged, like the cellular people talk a lot about 5G. It's more a set of requirements you fit into. So we can prove already the scale that you need in order to, let's say, get into the flexibility markets of in 15 years, where we need to connect, as I said, many more data points, many more transactions. Yeah? And Europe has a geopolitical issue. We need to be leading in that technology. In this point, we cannot rely on imported technology on companies that have a hand on either the chip side or the connectivity side, because that's crucial. That's crucial for Europe. And as Europe is a decentralized geography, decentralized decision-making, what is better than a decentralized 5G standard that is governed by the utilities, that is also part of the regulated entity. So government can really influence that as well. What is better than that?
Right, okay. So if utilities are thinking strategically about grid edge connectivity, what kind of approach actually balances affordability, reliability, and sustainability?
It's quite an interesting view to look at the energy policy objectives and apply that directly to the connectivity objectives, if you like. Why should they be any different? And if you step back and look at affordability, reliability, and sustainability together, well, RF mesh networks built on NR+, well, they provide this pretty strong balance. From an affordability point of view, RF mesh reduces dependency on external network operator fees. The network's utility controlled and devices pass data one to the other. And as you add more devices, the network grows naturally. And that improves total cost of ownership over long life cycles. So you're not just buying connectivity for meters, you're investing in a communication layer that can support new applications without new commercial contracts that need to be renewed every few years. From a reliability perspective, mesh networks, well, they're naturally resilient. Every device can relay data. If one device fails, the data simply takes another path. There's no single point of failure. And that matches the reliability standards expected in the energy infrastructure. And then, as Thomas was saying earlier, we have this dedicated radio spectrum, 20 megahertz of dedicated radio spectrum, which avoids all the congestion and unpredictability of shared bands and public networks. And then when we finally look at the sustainability, well, here sustainability means long-term stability and control. And NR Plus provides this communication infrastructure that's aligned with the lifespan of grid assets, which is typically a long time, especially in IoT and commercial worlds. And because the utility controls the architecture, it's not exposed to telecom network sunsets or shifting commercial priorities. And that lowers the long-term risk and supports future grid evolution as these flexibility markets and distributed energy resources, wherever they may be, they're definitely going to grow. Thomas, from the grid perspective, what do you think?
Yeah, let me elaborate a bit on that. Just a couple of sentences make it easy for the, let's say, for the non-technical audience to understand. The ideal situation is you install an asset or a meter in your home that should participate in a kind of mission critical grid control topics, and you just switch it on, and this device becomes automatically a access point, a router, and a sensor or actor in that network by itself. It's fascinating when you switch it on, but that only can happen when you decompose the connectivity layer from the communication and data layer. So we are working with DLMS-UA, for example, in a joint media compatibility. Yeah, and we can showcase that very soon. And we can work with any protocol on top. So the different life cycles of communication protocols and standards and connectivity protocols and standards, we are always matching with that standard without having to reinvent infrastructure or having big investments in kind of, let's say, like cell towers or something like that. And I think this is a role model for Europe, because that's exactly matching this triangle. We are dissolving the contradiction between reliability and affordability, because the more devices, the more assets you put into a network, the more stable it becomes. And what can be better for, let's say, for the unknown unknowns that we see in the future, and for serving the, let's say, 20 in Europe, the 27 plus governance rules on how these markets will be governed and what protocols will be used and so on.
Well, that's fantastic. It sounds very promising. Lots of potential, lots of growth in this market segment. Thank you so much for sharing your insights with us today. And of course, we're very proud to have Wirepass on board for SGT26 as the sponsors of our roundtable networking session. Perhaps a quick summary of what you're going to be sharing at the roundtable sessions, Thomas and Neil, and what you hope to take away as well before we wrap up.
Sure. So, yeah, I mean, we're really looking forward to the event in Paris at the end of March, where Wirepass will be, unsurprisingly, shaping the conversation around grid edge connectivity. And we'll host some roundtable discussions. And we really want to gather industry insights on what modern utilities truly need from their communication infrastructure as electrification and flexibility markets accelerate. So really looking forward to the roundtables, sharing ideas so that we can develop them going forward. And as well as these discussions, Wirepass will showcase our connectivity platform and services, demonstrating how RF mesh networks built on this NR Plus standard can deliver these nice, scalable and resilient and utility-owned connectivity networks for the evolving grid edge.
And maybe to make it even more exciting, there are not so many people out there who can talk about 15 million connected devices in the critical infrastructure. And
Sure.
I think that should be the trigger why anyone at SGT27 should talk to us, and we could share all these insights and learnings of the last decade.
We'll make sure that they're there at your table having this crucial conversation. Thank you so much, Thomas. Thank you, Neil. Great to talk to you, and look forward to seeing you in Paris.
Great. Look forward to seeing you too.
Thank you, Mandana. Merci.
Thank you. Join us again next time as we discuss another big topic shaping the future of the power grid. Don't forget to subscribe to our YouTube channel, Smart Grid Forums, and to follow us on LinkedIn. Until then, thanks for watching and listening.
This is Powering the Future, a podcast series brought to you by Smart Grid Forums. One planet, one power grid.